A block of mass m1 rests on a horizontal surface at the edge of the surface. A mass negligible fixed pulley is installed. It's installed over here. A light unstretchable string passes over the pulley, connecting the block m1 on one side and hanging mass m2 on the other side. A part. If friction on the surface is neglected, first, find the acceleration of the system. Second, find the tension of the spring. So for this question, again, we're using whole separate method. As you can see, this method can actually fit in a lot of scenarios in physics problems. So let's solve it. A. Let's write the net force equation for the entire system. F. So for block M2, right, it's pulling it downward. And then there's a tension force that resists it from going down, right? And for M1, there's a tension force that is equal to the magnitude of tension over here. And this tension is pulling it, it's like help it to move along the surface. However, also if there's friction, the friction will be like resisted from going along the surface. So let's write, so the net force is just m2g minus ft plus ft. Since there's no friction over here, we can just leave it blank. So this is your net force, and it's equal to the total mass times A, which is m1 plus m2 times A. And then you can get the acceleration, which is A is equal to m2g over m1 plus m2. This is the first part. On the second part, find the tension in the string. For the first part, you already got acceleration is equal to m2g over m1 plus m2. Now let's use the separate part in a whole separate method. Let's analyze mass 2. Write the net force equation for it. This is equal to, there's a gravitational force that grab it pulling it downward, right? And there's a tension force that pulling it upward. So the net force will just be m2g minus ft is equal to m2 times A. And you'll get F2. Ft is just equal to m2 times g minus, no, yeah, m2 times g minus A times g minus A. And then you can plug the acceleration to here. You will get Ft equals m2g times 1 minus m2 over m1 plus m2. This is your answer. Now let's look at B part. If friction on the surface is not negligible and the coefficient of the kinetic friction is mu, find the acceleration of the system. 2. Find the tension in the string. Although there's friction here, but you don't need to worry about it because I got you. It's basically the same thing, but just a little bit, complicated, only a little bit. So first, still using whole separate method, we can write the net force equation for the entire system, which is m2, right? M2 going downward, and there's the Ft pulling it upward to resist it from going downward. And then for M1, there's a Ft pulling it to move along the surface. However, this time we got a friction, which is pulling it backward. So we can write M2 minus Ft plus Ft minus Ff. We can simplify first, which is equal to M2 minus Ff. And it's equal to M1 plus M2 times the acceleration. Since over here, Ff is caused by M1, as we know, the function for friction force is equal to Fn times mu, right? And then over here, since the mass 1 is not moving upward or downward, which means it is at equilibrium vertically, which means Fn is just equal to Fg. Since the net force vertically is equal to 0, there's only gravitational force and normal force act on it, which means these two are equal. So Fn times mu can be written as Fg times mu, and is equal to m1g times mu. Let's plug it to here. Then we will get m2 minus m1g times mu is equal to m1 plus m2 times a. And we can get a is equal to m2 minus m1g times mu over m1 plus m2. This is your answer. Not that complicated, right? Now, second part. Find the tension in the spring. For the first part, we already got A is equal to, if I remember it correctly, is equal to m2g minus m1g times mu over m1 plus m2. And then let's do the separate part in a whole separate method. Let's analyze the mass number 2 again, because it's just easier. The net force for your mass number 2 is equal to m2g minus ft, because they're pointing in opposite direction, right? And it's equal to m2a. We can plug a over here, and we can get ft. First, let's move ft to one side of the function. We can get ft is equal to m2 times g minus a. And then you can plug in the acceleration over here. Then you can easily get ft is equal to m2g times 1 minus m2 minus m1 times mu over m1 plus m2. This is a simplified version. You can easily get that after you simplified like the complex version when you plug a to the formula. So this is your answer. It's not that hard, right? It's very easy. You got this.